topic 7. So we'll be discussing about SQL keys and their purpose. Basically, you might have heard about this primary key, foreign key, especially, and the composite key, and there are several other keys that we will be discussing in this video. But particularly, this video is about the SQL keys, and so we will discuss what is the purpose of using keys first, right? So we will understand why we need keys in SQL, and also we will understand how to exactly what are the different types of keys and how to exactly create these keys in practical, right? If you are new to this channel, before proceeding, if I would we would recommend you to please subscribe and also press bell button for instant notifications. So let's get started. Right. So let's understand first of all why we need keys. So we know that there are different keys in SQL. Most of us use the keys without sometimes without, like, we know the purpose, but we don't know the like end-to-end purpose of it, right? So we might be knowing it is just to create a relationships and like to identify uniquely, but let us understand what are the different advantages or what are the different needs that we need the SQL keys, right? The first thing is uniqueness and identification. So definitely, key is nothing but it's usually the primary key, especially, right? So it is used to ensure that a record in the table is unique, right? Suppose if you take a customer table, so the each record in the customer table should be uniquely identifiable. There might be a number of columns like age, address, pin code, city, but that can duplicate. But the employee, there should be some key like a customer ID or customer key which act as a primary key, right? So this makes it possible to identify and differentiate the individual rows from the table, right? And without primary key, so there would be no way to uniquely identify the reference and specific record. So then it leads to ambiguity if you're querying or if you're creating any report, so you'll not be able to identify a unique record in that, right? And the next is data integrity and consistency, right? So like let's take example of foreign keys, so which enforces referential integrity. So this means meaning that the relationship between the table remains valid or intact, right? And if a record in one table refer to the record in the other table, so foreign key is a key which ensures that the referenced record actually exists. Like, say for example, there will be a enrollment table, and the student ID is a foreign key, so must exist in the student table. So this prevents the record be getting orphaned, right? And the data might lead to inconsistency. So suppose in the deletion also, right? Like if there is a employee ID as a primary key in the employee table, and there is a salary table which will be referring this employee table, right? Which is having employee ID as a foreign key in the salary table. But if you delete the primary key itself from the employee table, um, which is having that employee ID and which is referred as a primary key from the employee table, so then there will be referential integrity constraint, because there will be the record might get orphan in the salary table, right? So that's how we meant it helps to identify and maintain the data integrity and consistencies. And the next one is the efficient querying and indexing. So like we might be wondering, how does this help actually, the keys, how does keys help here, right? So let's take unique keys and secondary keys. These particularly allow the database to create indexes, right? So because we have the keys and secondary keys, so we know which are the uniquely identifiable columns. So we can create easily the indexes, and that helps speeding up the any kind of search and queries. So when a key is indexed, so that helps in lookups, inserts, updates, and deleting will become more faster and efficient, right? So let's take example, an email column marked as a unique key allows for the fast lookups when you're searching for a specific email address in the user table. So that can be a primary key or unique key, and you can also kind of create an index on top of that, right, on that email column. Okay. So next is enforcing business rules. So let's take an example of a composite key. So we will come to understanding what are the these different keys, but let's just understand the need of keys here, right? So the composite key, let's take example of there is a student ID and course ID, which these two columns we can club together and say this will never be duplicated. So student ID is there and course ID is there. The combination of these two will never be duplicated. So this creates a business logic. Okay, so you can create a, by combining these two, you can create, say for example, a course registration number. Okay, so that is just enforcing the business rules. Okay, and you can think of a number of possibilities doing those, right? And maintaining relationship between the tables. Yeah, this is again a referential integrity where you have foreign key, primary key, there is a order table, customer table, right? So foreign key ensures that for every order there is a corresponding corresponds to a valid customer, so that's which is quite important, right? And then the next thing is preventing duplicate data. Okay, so you can have a unique keys created, right? So which helps to prevent the duplicate data by ensuring that certain columns contains only unique values. Say for example, in a there is a driver table, the license number can be called as a unique key, so which ensures so no two drivers can have a same license number, right? And few more we have. There is a data normalization also, which supported by the keys. Keys supports the normalization process, which reduces the data redundancy by organizing the data into different related tables. By breaking data into smaller tables, right, related to related tables and using the keys to connect them, we can avoid the storing the duplicate data. So normalization is a different topic altogether, where we kind of split the bigger table into smaller tables, so to kind of avoid the duplications. So to support that, so when you are splitting the tables into multiple tables, so definitely you need something to connect between these smaller tables, right? So which maintain the relationships even after breaking the table. So that is what the data normalization is, and that is what specifically the keys does, which still maintain the relationships, right? Say for example, instead of storing a customer data repeatedly in multiple tables, we can have a customer ID as a foreign key, and can refer a single record in the customer table. Okay, so next is enforcing nullability constraints. So keys helps enforce null constraint. For instance, like if you have a primary key, so that definitely doesn't allows any nulls, because that is a primary key, right? So obviously that should have some unique value, ensuring that every record in the table is uniquely identifiable and no record lacks a particular key. And the simple example is employee table. In employee table, you have an employee ID, which is a primary key, which ensures that every employee has a unique and non-null identifier. So then we have facilitating complex queries. Okay, so this is again important thing, right? So you might be having a good reporting layer, you want to build a good reporting system, but it also depends how efficiently you use the keys, right? So that's why you need to define a relationship between the tables using keys, so that you can easily kind of create the complex queries, right? Using the SQL database that you have, you can create a complex queries, aggregations, and also you can have multiple tables joining with each other. Okay, for example, you have a order table joining with customer table and then joining with product table. Okay, so then again joining with some sales table, right? So using foreign key to generate these reports and analyze the trends by connecting to multiple tables. So all this reporting will be done using joins, right? So you are joining the different tables and you are aggregating the data and finally generating the final report, with which will have certain KPIs for the analysis, right? So yeah, that's kind of pretty much important here. So like let's jump to the different keys we have, right? So these are the different keys we have. So primary key is basically it uniquely identify records, and foreign key maintains the relationship between relationship and data integrity between tables. Unique key is something which ensure the uniqueness of a specific column. So it is, you can think of it as a similar to primary key, but you don't want to make it as a primary key. So you just want to create a unique column, okay? Because the primary key can be different and the unique key can be different. Okay, so next is like where we have a super key. So super key handles complex identification needs in multi-column uniqueness scenarios. And you have like surrogate key, right? So surrogate key basically it helps in kind of creating a combination of multiple keys. Okay, so that we will see surrogate key is actually basically not a composite of multiple keys. Composite key is a composition of multiple keys, but surrogate key is something which automatically generate the unique values in order basically. So that we will see in a while what exactly these different keys are and how exactly we can create the keys, right? So next, let's quickly jump to the practicals of it and let's start understanding. So now let's quickly come to the practicals and see how do we create a primary key first. So primary key, as you can see, so whatever we are seeing, the syntactically it might be a little different if you use MySQL, if you use like say for example Vertica, IBM DB2, and PostgRE SQL, right? So the different databases slightly have a different syntax, but here we are using SQL server. So we can create a table just like this, right? So you have a create table and so here what we are doing is a student is a primary key and which is an integer. So we created a table. So now the table is created. So you want to insert a record into the table, right? So let's try to insert a records into the table. So as you can see, you can just insert the records and it inserted a record. But again, if I try to again insert the same records here because one is already existing, two is already existing, three is already existing. So that is why it says cannot insert duplicates into this statement. So it's violating the primary key constraint, right? So this is about the primary key simply, okay? And so most of the people might be knowing what is primary key and also what we will be going to see now, which is a foreign key, right? So foreign key is again, let's take example of we have a student table and we don't have a course table. Let's remove the course table and just refer to the students table here, right? So now, so this is basically it is referring to the student key, student ID. Okay, so let's see insert statement for this. How exactly the insert statement look like? What we are saying is we have already have a student table, right? And now we have an enrollment table which is also having enrollment ID but also having student ID. But the student ID in this table is referring to the student ID of the other table which we created already, right? Uh, let's take the enrollment ID, student ID, and then course ID, right? So we can have this inserts here. Okay. However, let us try to insert one more record. Okay, just for the understanding purpose, where we will try to make it as say 2010. Okay, which is 10 is a basically it's a course ID. Like second one is the student ID, right? So yeah, student ID we will make it as 10 or 11. But student ID 11 doesn't exist because right, so we have already seen. So as you can see, it cannot insert values here. So it is having to, first of all it is a duplicate constraint. So let's remove the duplicate constraint by changing the key here, which is enrollment ID, and try to again insert. But again now it failed because of this particular 11 that we are inserting, because 11 is nothing but a student ID, but in the student table 11 doesn't exist. So that is why it's a referential integrity constraint, that is a foreign key constraint. Okay, so this is about the foreign key in a simple example, right? So this here we are making sure that the referential integrity is maintained, right? So now let us see about the employee one more employee table where we say this particular email is a unique key. Employees already exist, so we'll make it as employee v1, right? Right. So we have so as you can see, unique and primary key logically means the same, but when it comes to practically implementing them, so a unique key can be different than a primary key. Primary key is basically, as you said, it can be referred in other table, it has its own use for maintaining the referential integrity, but unique key is specifically for maintaining the uniqueness. Primary key is both for uniqueness and also having the referential integrity where you can maintain that, but this is completely different. Okay, so now once we have this inserted, let us try to have a uniqueness check by inserting some records. So we inserted, okay, this is email employees v1. Okay, So we've added, okay, but now we will try to insert one more value, okay, which is having essentially a different key. Okay, it's a 4 key, but the email is same. Okay, so let's try to insert. So as you can see, it is a unique key constraint we have enabled on email. So that is why you cannot add the same email again in this table because it's already added with the employee ID 3. So this is about the uniqueness. How we kind of maintain the uniqueness. Okay, and the next is a candidate key. So we'll take an example of candidate key. So candidate key is also again a unique key. So where both book ID chosen as a primary key and ISBN are candidate key. So candidate key is a very similar to it's just a nomenclature what we call it as a candidate key, but it's also ensuring the uniqueness. Okay, and we have something added as a super key. So super keys again it's a combination of unique keys. Okay, like let's suppose you have a order ID, customer ID, and product ID. And order ID is a primary key, but you want to have the customer ID and product ID combination as a unique key. So because this is a combination of two keys where we are calling it as a unique, so this is considered as a super key. Okay, so now this is created. So we will try to insert some record into the order table and see how exactly it looks like for super key. Yeah. So what we said is the order ID, customer ID, product ID. In this, customer ID and product ID. So these two combinations should be unique. Okay, as you can see, this combination is unique here, and this combination is unique, and this combination is also unique. Okay, so the like let's try to insert this. This will insert, correct? But if I try to create again the duplicate with respect to this combination, like again I'm inserting these two combinations, so then it will throw error. Okay, because these through are the okay, let's just giving the primary key constraint. I'll change the primary key and re-execute. Yeah, so now you can see the unique key constraint is a problem here. Okay, because these two combination is not a unique because it's already there. Okay, so this is a unique key. It's a advanced version of unique key where you are using a super key. Okay, then we are calling it as a super key. Okay, so then we have a composite primary key which is called as composite key or composite primary key where you use a combination of student and course ID here. The combination of these two are considered as the primary key. Okay, not only one key but combination is considered. Okay, so that's how you want to uniquely recognize the record. So that is the only purpose of creating this kind of key here. Okay, so let's try to again insert some record for this. Okay, so now again if I try to insert combination again it violates the constraint, but one key you can change, right? If you change one key it will allow to insert you, right? But the combination should be unique. Okay, and going forward, so there is something called as surrogate key. So let us discuss about that. So surrogate key is auto-generated, auto-incremented value, as you can see, right? So it depends on auto-incremented. So basically, if you want to have the SQL version of it, you can use something like identity 1 comma 1, which means increment one value for every record that is inserted into this. Basically, the product ID is auto-generated. You need not, when you are inserting the record into the product table, you need not enter any value to this. Okay, so you can just insert the values. It will just insert the values. Okay, so as you can see, insert into values, insert into products, right? So insert into products, you can just insert values, like only for name you can insert the values. Okay, we can just give as a name and then give values. Then you can have laptop. Yeah. So as you can see, we are able to insert a record. Okay, but let's try to query this table and also see. select star from this table, products table. So the laptop is inserted, but the product ID one we have not asked it to insert, right? So let's add a TV here. So the automatically the two will be added here, product ID. So product ID is getting auto generated. You just need to insert. So wherever it is a identity column or auto incremented column, which is called as a surrogate key. So you not insert a value, it will be automatically inserted. Okay. So these are the different keys. You can just practice around these different keys and like comment in the comment section if you have any particular questions. Hope this was useful and thanks for watching.